Okay, thanks for having me here today. My name's James Davis. I work for Janet. Some of you already know me, but it's my first time here at UKNOF, so I'm new to some of you. I've worked in Janet now for about 7 years in what was our CERT team and is now our CSIRT team, so dealing with incident response for the academic community. And what we're going to talk about today is how we deal with botnets and malware on a network the size of Janet. I thought I'd start by giving some background. I know some of this is going to be fairly familiar to an audience like this, but it's worth going over. So IP is starting to get everywhere. When I was at university, which wasn't all that long ago, if a student brought a device with them, it might be a laptop, it might be a desktop PC. It wasn't all that unusual for students to bring nothing at all with them. If you had an Ethernet in your halls of residence, that was quite swish and nice, and things were nice and simple. But these days, students expect to be able to bring a lot more. Devices like Kindles, iPads, iPhones, Xboxes, Wiis, PlayStations. Students expect to be able to use these all, especially in their halls of residence. Wireless printers. They expect to be able to connect these up to your networks. And as you mentioned before, there was the IP-enabled toilet. I'm not quite sure why you need that. I think there was a security vulnerability in those IP toilets that allowed you to remote control them or something. But the one on the top right is a smart meter. Lots of universities are starting to deploy these now. Having your environmental credentials is quite a big thing. Be able to monitor energy usage throughout a campus is quite important. Things like building management systems starting to come IP-enabled. I've never seen an IP-enabled washing machine, but apparently you can get them. I'm sure they'll turn up in the halls of residence sometime if students actually wash. The middle one is an IP-enabled barbecue. I'm not really sure what the point of that one is. For me, when I barbecue, I like to go outside and get away from it all, but some people like to barbecue from the comfort of inside, so... But the point is that mostly, we're starting to find IP everywhere, and for most of these companies, they're a barbecue company or they're a washing machine company. They're not an internet company or a networking company. All they're doing is the electronics and buying their IP-enabled widget to add this on. They're not networking companies, and security is not really a factor in the design of these devices and or the support of them. But they're coming on our networks anyway. And students are expecting to get internet access everywhere. I think I was speaking to one of our customers earlier in the year, and they were doing a wireless survey of a new building, and they were even doing looking at the signal strength in the toilets. Again, people expect to get this Wi-Fi everywhere. And this is important to a university because one of the rankings that they get these days is not just on the academic ability or the research ability of the university, but also on the student experience. So it's quite interesting actually looking at rankings of universities on that. It's not the university you'd expect, but ranked quite highly. And in this respect, if you have an overly draconian IT policy that says you can only connect Windows laptops or Linux laptops or iPads, then that's going to be counterproductive. Your students aren't going to enjoy it, they're going to be complaining. And when it comes around to doing these rankings, the universities are going to suffer. And then from a perspective of a network provider, when I started at Janet, it was quite easy to block IP addresses that we saw doing sort of abusive behavior on a network. If we blocked a university's install of Moodle, well, they were still working out what they wanted to do with Moodle or a virtual learning environment at that time. It was quite easy to just say, no, block this from the network. It's not going to cause all that much harm. But these days, if you blocked a university's virtual learning environment, I would have angry people on the phone straight away. Not be a happy day at work. I don't know what happens if you block an IP fridge from a network. I hope it still works. IP pacemakers. I think someone somewhere has created an IP-enabled pacemaker. I don't want to think about what happens when that gets blocked. I hope it just stops reporting to the GP, but but more to the point is, as a network provider, can Janet make these calls anymore? Can we just simply block things? It's getting more and more difficult, especially with NAT being used even more. So there's a growing number of devices on our network that the owners of those devices and the vendors of those devices don't consider to be computers in a traditional way, and the security of these devices is not supported in the way that we might hope and expect. Point of sale systems are ones that often causes problems as well, so you often find they've got embedded versions of Windows that aren't being patched and managed. Many of these devices are unmanageable. You could tell your students that all their Android devices have to be registered in some corporate management system, but it's not going to happen. Students aren't going to want to do that. Many of these devices are going to be vulnerable, out of date, and so as a result, some of these devices on your network are going to end up being in botnets. I would hazard a guess that every university in the UK is infected somewhere with something. And the state of play in malware at the moment, well, botnets don't need to be particularly sophisticated. CONFICKER is still a big problem for us, despite the fact that the vulnerability that it uses was patched 5 years ago now. So it's still quite shocking to me that 5-year-old versions of Windows are still in use, but the other day I did come across Windows 3.1, so maybe not so much. Zeus, which was first released in 2007, is still one of the most popular sort of Trojans that we come across. It's still being used today, new variants of it to steal banking details, and we still come across infections of this every day. So I hear a lot of people always talking up the threat of sort of cyber espionage and APT and Stuxnet and all these sophisticated attacks, but in reality we're not even looking at the low-hanging fruit here. Things like CONFICKER and Zeus are still quite prevalent in the world. And so, at least from my perspective, I'm going to start focusing on these immediate threats that we know and understand, rather than trying to find out super Chinese spies who are, One person asked me, if they're that sophisticated, how do you know if they've broken into your network at all? So, just to give an extent to the problem, there's about 1.3 million CONFICKER infections in the world at the moment. It's gone down from about 2.3 million a year ago. These are all statistics from shadowserver.org if you want to go and look them up. This is the botnets that they're monitoring. Currently it's at around 2,500 botnets. You can multiply that by 100 or 1,000 to get an idea of the number of affected machines here. So one of the things that our customers have the option of doing is running an intrusion detection system to try and pick out these infections on their network. And for most of the malware that we see, they communicate in known and predictable protocols. So whenever something new, like a new variant of Zeus comes out, it's usually analysed pretty quickly, and in various security sharing forums, the information on how it communicates is shared and distributed amongst teams like my own. Systems such as Snort can usually detect a lot of these infections. You can think about the ones that use clever encryption and peer-to-peer and Tor. These come out time to time, but they're usually quite easy to detect the common infections we see. And that, the other complaint about IDSs is that if you have a huge array of signatures, that you're just going to get overwhelmed by false positives. But if you're just looking out for one particular malware infection, then just having a small number of signatures for detecting some well-known malware can actually have some good results. So I know a few customers who are just using Snort to look for Zeus infections, and they find it really useful. It's quite easy to implement an IDS if your network is slow. If you've got a 1 gig network, then it's fairly easy to deploy and get started, just with hardware you have lying around. Around 10 gigabits a second, it starts to get interesting. You have to do some intelligent filtering. I think you can get implementations of Snort that have been compiled to work on FPGAs, which I find really interesting, but it's also really expensive. I think you start looking around £10,000–15,000 per sort of network tap around that point. I've no idea what you have to do at 100 gigabits per second. I think it gets really expensive. I did ask one vendor for a quote, and they said Janet couldn't afford it. They sold their solution to a small nation state, and it took up 40 racks. It's not something we're going to do. And also, some organisations like to do IDS on a huge scale. They like to capture all traffic coming in and out of their network. It's quite popular with defence companies at the moment. They want to have that full ability to look at forensics on their network. But I don't think that would be very popular with our customers. Terms like DPI and NSA, not really the thing we want to be doing. And that's forgetting the whole legality of doing this anyway. So what we do instead is we use NETFLOW. I'm sure many of you are familiar with it. So we move away from capturing all the packets on our network, and we're just looking at sort of level 3 metadata. The good thing about this is most of our routers already do NETFLOW to some extent. We've already got the open source tools to deal with this sort of data, and I'm going to cover those in a bit more detail later in the talk. You can also buy commercial off-the-shelf systems to look at NETFLOW. We haven't done that because they're really expensive. I was quite shocked last time I priced one up and they charged delivery for it when the cost was into 7 figures. There's a lot less data to process, which is a good thing from a data management perspective. Processing NETFLOW for the entirety of Janet takes a 7 terabyte disk array, which is affordable. It's relatively cheaper, and there are sort of fewer legal and ethical issues when involved in doing deep packet inspection. Some of the problems are that not all routers do NETFLOW so well. Some of them don't have chipsets in them to export NETFLOW very easily. It depends what routers you have, what software you're running. The open source tools are not very user friendly. They probably are to an audience like this one. If you can use TCP dump, then they're probably not all that difficult to use. But in terms of some of our customers, especially in further education colleges, it's just not the sort of tool that they want to be using to analyze network data. As well as being really expensive, the commercial off-the-shelf tools are really targeted at enterprises. They don't really look at the service providers, and I found it quite difficult to integrate them with our workflow. They like to generate fancy PDF reports suitable for presenting to management, but they don't want to send out sort of text alerts and emails to message and incident response team. NETFLOW is also sampled, which becomes a problem, and also I think that some of the limitations of the data in NETFLOW aren't widely understood, and people don't really understand the questions that they're asking of the data and how this limited data impacts that. So we quite often have people asking us, where is our network traffic going? And we can tell them, well, the traffic's going to YouTube, but that doesn't help them decide whether this is actually a legitimate teaching use of YouTube or whether it's actually pictures of kittens falling over. So NETFLOW is not going to be as good as an intrusion detection system. It's going to be a lot cheaper. Not everything is going to be detectable using the information we have, and we're going to miss some of the things that we can detect as well because the data is going to be sampled. But it's relatively cheap. It's something we can do now using the tools that we already have to hand. So the tools we use is a package called NFDump, which is actually maintained by Switch, the Swiss educational network. Actually looked after by a guy called Peter Haag, who's an expert in all things NETFLOW, and it's pretty much like TCP dump. So like I said, if you're used to TCP dump, then you can pretty much just sit down and start using NFDump. NFSen is a graphical front end to these tools. It's essentially just looks like MRTG, but you can zoom in and filter some of the traffic in some ways, and produce summaries and aggregate statistics. There's also Flow Tools, which we've made quite a lot of use of in Janet, which is an older software package that's no longer maintained. Doesn't really support NETFLOW version 9, or now known as IPFix, which you really need if you're going to be monitoring IPv6 networks. We also use a small little program called Samplicator, which is quite useful for sort of multiplexing and manipulating UDP packets. This is the architecture of the system we've built. We have a number of network devices, routers and firewalls and switches that are all sending NETFLOW data into centralized collectors. In some cases there's a tier of collectors, but eventually they all end up on an analysis box where they're sent to various different scripts. So one of the basic things we can do is simply archive all this data and store it somewhere. Just using the native toolchains, you can just write the flows straight to disk. This is actually really easy. It's really quick, really fast, really cheap, both in terms of money and computing power. It's very slow to actually query. If you've got several gigs of NETFLOW data to search through, it can take some time for your query against it to complete. So if you wanted to look against the last week's worth of traffic on Janet, then your query might take a couple of hours to finish. That may actually be acceptable. At one point for us it was. But we got a bit fed up with the limitations after a while. You can stick all your NETFLOW into a database, and the tools like NFDump and the Flow Tools toolchain will allow you to export data into MySQL or Postgres, and that gives you a lot more flexibility. With indexing especially, you can search through it a lot quicker, and you can start referring back to other flows and doing more complex queries. It does get really intensive, very expensive, it doesn't scale very easily either. So in the future we thought about maybe trying something like Hadoop. I know a couple of other networks that have tried this approach. I played with it a little myself but not really got very far. It allows some interesting possibilities but also provides some interesting problems to be solved. You can also filter through the NETFLOW traffic very quickly. So if you've got activity where a botnet communicates with a known bad host, then it's very easy just to filter through the flows as you receive them and generate information based on that. So things like CONFICKER, where we know it only communicates with a small and limited set of IP addresses, we can identify traffic really quickly. Essentially, NFDump will allow you to write a TCP dump-like query, and you can just wrap them up in some scripts and send it out to your customers. You can start to build dynamic filters if you've got sources of bad IP addresses. So these are two sites we use. So you can get lists of Zeus infections and then try and match NETFLOW against that. Using the database, you can start to do some even more interesting things. You can try and pick up port scanning by matching SYN packets going in one direction against SYN and NAC packets coming back in the other direction. That used to be more useful to us in the past, but we found doesn't happen as much on our network anymore. One of the things we pick up most by port scanning is actually infected iPhones. Tend to scan out on port 22. Or if you saw a connection going to a host, say for MySQL, followed by scanning from that host for MySQL servers, you've got a pretty good idea that that system was infected by some worm and is trying to spread again. So as a result of all this work we've done, we've been able to offer near real-time detection of simple malware like CONFICKER to our customers. Most customers don't actually want us sending 100 emails a day to them about repeated infections, so we tend to summarize it in a report for them. But as a result of this, I think we're the third largest address space in the UK, but if you try and sort those same address spaces by number of infections, then we're the 37th most infected in the UK. So I think that's quite impressive. The stats there are sourced from the bottom, from Shadow Server again. We can also perform forensics using the archive of data that we have. So if we know that a system has been compromised at a particular time, we can start looking for suspicious connections to that host. And from that, then we can start to build a picture of what else has gone on. So quite often we'll find one infected machine or one compromised system, and then find that the attacker is connected out to other systems on Janet, and detect those, whereas previously they might have gone unnoticed. In a few cases, we've actually found that the attacker has been one of our own users and has then, from the same system, logged on to their webmail at their home institution, which has made for some interesting conversations. How am I doing for time? Okay, almost finished. So I thought I'd finish off with some news about what's going on in the CERT community in the UK. There's a project that some of you may know about called CISP, which is a sort of public-private partnership being run by the Cabinet Office. It's the Cyber Security Information Sharing Partnership, and the terrible way to describe it is like a Facebook for sharing security intelligence. It's essentially a web portal that you can log into, and within there are various open and closed groups that you can join and share information on activity that you're seeing on your networks and your systems. I'm finding it actually quite useful. It's a good way of reaching out to sort of other industry sectors and seeing what they're seeing and sharing that with them. There's quite a lot we've been able to learn through it. If you want to join, you do need a reference, so come and catch me and speak to me and I can sort that out for you. There's also going to be a national CERT team being formed called CERT-UK. This was originally announced back in December of last year as part of the update to the UK's cybersecurity strategy. I don't know much about it. I did send them an email asking if they wanted me to tell you more about it, but they didn't get back to me. I believe they're going to bring together the existing .gov.uk CERT teams under sort of one unit, bringing together all their expertise. And CISP will then become the sort of situational awareness wing of that effort. That's the end of my talk. Any questions?
Hi, Terry Froy. I actually work for one of your customers. How much abuse have you seen from VC networks?
Very little. Mostly spam.
Okay. Okay.
What, spam or abuse?
This isn't the abuse desk. If you want spam, you have to go to...
Yeah, so essentially, the only way we can monitor IPv6 is with IPFix. Not all the routers on Janet currently export that to us, but in the parts where they are, we haven't really seen anything yet. Any more questions?
Ilya Voroshkin, Ezinet. The question is, when you resort to detecting botnets using just NETFLOW, you would be basically just trying to identify very primitive botnets, and have you considered if this is actually very much relevant? I mean, if you fix these kind of problems, how much percentage of overall botnet problems you are actually fixing? I mean, is it worth bothering?
I don't know, but this is all we can do. We can't do any deeper inspection of the traffic, so this is what we have available to us.
Because once you have identified flows, it should be fairly straightforward just to use open flow, flow specs and get edge routers to filter it. But the traffic you could identify with flows, some kind of SYN attacks, you wouldn't be able to identify stuff like, oh, this botnet tries to steal passwords from users.
No, we can't do anything like that.
And I guess the malicious code goes towards more sophisticated attacks rather than just sending SYN flood to devices. Yeah. SYN flood is probably like end 90s.
Well, we don't detect SYN floods, but the more sort of advanced malware where you're only going to detect it at the sort of...
Is there any research into what is what portion of the malicious things you are fixing? Or
no, I can't tell you about the things I don't know that aren't happening.
Okay, thanks.
Okay, Tim?
Tim Chan, just a quick question. Do you do BCP38 on university traffic coming into the Janet core, and if so, do you have any idea of the sort of level of spoof traffic that might indicate badness?
No, we don't. Difficulty is the asymmetric routing doesn't really allow us to do that. I believe on the routers where we manage, Rob's going to speak up and correct me because I'm probably getting it wrong. I'm not a network person.
Well, yeah, we do anti-spoofing on the connections to our customers, but we don't log the amount that's being rejected.
Okay, thank you very much. Oh, okay.
Is that because it's not technically... So is that because it's not technically possible, or you just haven't bothered, or what?
Haven't really bothered.
Okay, so it could be done.
There are packet counters, and the counters go up. The counters go up a lot, but we haven't looked at in any detail at what that traffic is, because we've just assumed it's all sorts of random rubbish.
I'm trying.
Rubbish from universities, never.
I'm trying to figure out whether Rob and Tim are having a split horizon or hidden station problem here, but due to the nature of the venue, they can't see each other. But anyway, thank you very much, James.
Thank you.